Today we'll try to solve one more example with the help of FindS algorithm. First example I have solved in my previous video. The link of the same is available in the description part. I would rather say go with the first video and then come back to the second video and then try to solve this particular problem along with me. So the data set that I have considered over here has got 4 training examples. And then in each, we have 5 different attributes over there. One among that instance is a negative instance, and rest 3 are positive instances. We all know FindS algorithm works only on positive instances and not on negative instances. So let's begin with this. We know initially we are supposed to consider an hypothesis with the most specific values over there. So you can write over there H0 equals to, you can say null over there. I'm writing it in this fashion instead of using an image over there. And I'm going to write over there 5 times null value. That is because we have 5 attributes in this particular data set. Now what I'm going to do is I'm going to match these values with the first example, training example over there. So the values in the first training example are some, small, no, affordable, and 1. So when I try to compare the values in hypothesis with the values in the example, you know that when the values are matching, we are supposed to perform nothing. But when the values are not matching, then you are supposed to replace with the more general value over there and so on. But in our case, all these values are not matching with the first example. It is classified as no and expected is no. And as we know, FindS algorithm is going to work only on positive hypothesis. So then what I'll do is I'll consider H1 equals to H0. Okay, because the first instance over there is a negative instance. Then coming with the second, when you want to find out your second hypothesis over here, H2, you are supposed to compare this with X2. So now you compare the values of X2 with the values of your H1 or H0, one and the same over there. So the values in X2 are, you have many, big, no, expensive, and many. Whereas the values in our H1 or H0 are null. So none of these values are going to match with this particular values. So it is expected to be negative, but it is classified as positive. So what is that we need to do? When it is a positive instance, you are supposed to replace this value with the more generic value or general value over there and so on. So you will write over there H2 equals to, so compare with the first null, many. So the general value over there is many. Likewise, you compare with big. So the value is big. The third value is more, and the fourth is expensive, followed by the fifth one as many, and so on. Okay. Now coming to the next, you need to go with the next example over there. That is X3, and then try to compare the values with the given hypothesis. Now what you are going to do over here, these values you are going to match with the values that are present in your example 3. Example 3 is classified as a positive hypothesis over there. So what you are going to do now, these values you compare with example 3. Many matches with many, so you can write many over there. Then big matches with medium, there is no match, so you go with the more general value, which is question mark. And then no matches with no, so you can write no over there, followed by expensive matches with expensive, so you can mention that over here. And then finally, many matches with few, the answer is no, so you are supposed to go with the more general value over there, which is question mark. And then lastly, the final step over here. What are you going to do? You are going to compare this hypothesis values with the last example over there, that is X4. So what then happens? So when you try to compare it with X4, X4 over here is classified as a positive hypothesis. Whereas you try to compare these values now with the values in X4. So many you compare with many, so it is matching. So you write as it is. Question mark matches with any of the values, so you put question mark over there. And then no matches with no over here, so you can mention the same value over there, followed by expensive matches with affordable. The answer for that is no, so you are going to have a question mark over there. And finally, question mark matches with many. The answer over there is yes, and you are going to write it with the most general value over there. So that means when you try to solve this with the help of FindS algorithm, you got the most specific hypothesis as H4 equals to many, comma, question mark, comma, no, comma, question mark, and question mark. So this is considered to be the most maximally specific hypothesis. So in this way, you can solve n number of problems with the help of this particular algorithm called FindS algorithm. Once again, I repeat, before you come to this particular stage, I want you to go with the previous video for which the link is given in my description part. Then we'll try to understand over here what exactly we mean by consistent hypothesis. This particular concept is important for us in order to go for the next algorithm, what you call it as candidate elimination algorithm. So wherein we need to check for the consistent hypothesis. So what exactly you mean by consistent hypothesis? So there is a data set which is given to us wherein you have two training examples and then two hypotheses are given to us. Now you need to find out whether hypothesis H1 is consistent and H2 is consistent or not. We are going to say hypothesis H1 is consistent with this particular training examples only when the values of this matches with the values of your training attributes and so on. So what we are going to do now, try to match these values with the examples given over here. So H1 I'll try to match with the first example over here. 3 question mark, S normal and question mark. 3 question mark matches with these 3 values. S matches with this, normal matches with this, question mark matches with this. So it is classified as S, that is a positive hypothesis, and expected is positive only. So it is consistent with the first one. Now try to compare with the second. Question mark, question mark, question mark matches with these 3. S over here matches with this S. Normal is not going to match with high. So it is supposed to be a negative hypothesis. And given over here, it is negative. It is classified as negative, and as it is not matching, it is desired to have a negative hypothesis. So this particular hypothesis is matching with both the training examples over there. So I can call it as consistent hypothesis. So once again, I'll repeat, these values you are supposed to match with both the examples that are given over here. In the first case, all the values are matching and it is classified as yes, and the desired is also a positive hypothesis. Then coming to the second example, it is not matching with the second example and it is also classified as no. So in that case, we say it is a consistent hypothesis. It should match with all the values when the hypothesis is yes, that is when the instance over there is yes, and it should not match when the instance over there is negative classified and so on. Now try to do this with the second one. H2, question mark sunny, question mark yes, question mark, question mark. So this matches with the first one because there are two values over here called sunny and S. So it matches with the first one. It is classified as yes, and the desired is also S. Then coming to the second one, question mark matches with evening, sunny matches over here, question mark matches with this, S matches with this, and then question mark matches with this, strong also matches with this question mark, but it should be classified as S, but given over here it is no. So it is not consistent with the second example. So we say this hypothesis 2 is not a consistent hypothesis with this particular data set. I'll repeat, these values which are given in the hypothesis, I'm going to match with these two examples over there. Now, as it matches with the first example, it is classified as yes and the desired is yes. Whereas when you try to compare with the second, it is also matching with the second example. Desired is yes, but it is classified as no. The reason we are going to call it as a negative hypothesis, that is inconsistent hypothesis, and so on. So I'm going to write it as inconsistent over there and so on. Inconsistent over there because it is not matching with the second example over there and so on. So if you like this particular video, please share my video with your friends and do subscribe to my channel. Thank you.